This is a proportion of students who score a certain proportion on the assessment tool. 70% of students, so the first proportion is a proportion of students, will score 70% or higher. So this is really their score. Okay, so we take our make-believe data set here, and I just copied and pasted the data, the final exam column, the lab and the lab proportion column, the performance and the performance proportion column, those are from before. And I added these columns: final success, lab success, performance success. So if my standard of success is 70% of students will score 70% or higher, these are my scores for this tool, final exam. And I'm going to go through and look at which ones are 70% or higher. This is a yes/no question, okay? And this is where the binomial distribution comes in statistics. Yes, 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 no. Yes, yes, no, yes. Okay, so I'm just going down. Is this number greater than or equal to 70? Okay, so yes or no. Well, you need to translate the yes or no's to a proportion. So then you could add up all the yeses and divide by the total number of responses. But instead of using yes and no, use ones for yes and a 0 for no, because then all you have to do is use the sum function in your spreadsheet and add up this column, and you'll get the total number of successes here. So there were 18 of these scores that were 70 or higher out of 20. So the proportion of successes is just take this number and divide by the total, divide by 20. For the lab proportions, you go through any number here that's 0.7 or higher gets a 1 in this column. Anything less than 0.7 gets a 0. There were 16 out of 20, so 0.8. So my proportion here is 0.8. Same thing with these. 0.7 or higher gets a 1. Less than 0.7 gets a 0. 15 were 0.7 or higher, which is 75%. So 15 out of 20 is 75%. These numbers down here, the blue numbers, are the proportion of students that scored 70% or higher. These are the numbers down here that we're comparing to 70%. In all three cases of my make-believe data, my standard of success was met. 90% of the students who took the final scored 70% or higher. 80% of the students who did the lab scored 70% or higher, and 75% of the students who did the performance scored 70% or higher. Okay, these numbers are arbitrary in the sense that there's nothing special about them. They're considered to be, reasonable for sort of non-mathematical reasons, but they don't have to be those numbers. And one of the things that I think can be confusing is that they're both the same number, 70% in both cases. And so I think that kind of leads to it's the 70. I think the person I was helping was kind of looking at this and thinking this was maybe just repetition, like 70% and then the 70%, just to remind you in case you forgot, it was 70%. But we could do, for example, 80% will score 75% or higher, and then change these numbers. Now, I'm not saying that's a good thing to do, but just for example, how would that change the data? So it's the same data, but the only thing that's going to change is our successes. So now I'm going to go through these, and I'm not comparing to 70%, I'm comparing to 75. So this 72 was a success before, but now it's a failure because it's less than 75. So that's a 0. These are still all ones. That was a 0 before, it's a 0 now. 76, those just made it, etc. I had, I think, 18 before. Now I lost a couple. So now I'm down to 16. 80% of these students scored 75% or higher. But I also raised my standard here. Before it was 90%, which blew away the 70% that we were comparing it to. And now it just barely made it. 80% hits the cutoff. 80% did indeed score 75% or higher. But with the lab, only 60% scored 75% or higher. So comparing these numbers to 75 gives me these successes and failures. And with the performance, 75% scored 75% or higher, which is actually the same as before. But that now, because I changed this threshold, also fails to meet it. So now, in the first time around, all three tools, standards of success, were met. And this time, by changing these numbers up here, this one is met, these ones aren't. And just to show that these aren't the same, if we swap these and say, well, let's change this one to 75 and this one to 80, now I'm going to say, how would it turn out if I said 75% will score 80% or higher? Now I'm comparing these numbers to 80. So I'm going to get a lot more failures. Anything in the 70s, the 76, the 77, those are going to be failures, the 79, the 70. So now I only have 13 out of 20 that scored 80% or higher, which is 65%. 60% scored 80% or higher on the lab. 75% still scored 75% or higher on the performance. And this one now is satisfied because it just barely made it. 75% scored 80% or higher. higher. Okay, something you might have noticed is this performance tool, though I changed this standard 3 times, these results didn't change. It was always 15 out of 20, which was 75%. We just look at these two numbers here. If I go back to the previous one, 80% will get 75% or higher. It's still 15 out of 20. And then the original 70% and 70%, still 15 out of 20. So how did this happen? Well, if we drill down a little bit and look at this, one of the reasons this happened is because there's only 5 points possible on this performance. So you have a 5-point rubric here. There's only 5 possible values for the proportion. You could have a 0, you could have 20%, 40%, 60, 80, or 100%. Anything that's above 60 and below 80 is the same. In other words, my cutoff here is 70, smack in the middle. So a 60 fails and an 80 passes, is a success. Well, if I change the cutoff to 75%, well, the 60 still fails and the 80 still passes. And if I change the cutoff to 80%, the 60 still fails and the 80 still passes. So all of this is the same. And changing this second percentage doesn't change any of this. And if I change the first one, well, that's just changing the number that I'm comparing the 75% to, but the 75% is still the same. Okay, so this leads to one of my caveats, which is make sure your rubric and your standard of success are compatible. The other one is don't average averages unless you know what you're doing. All right, so this is, again, just made up data, exaggerated for the purpose of illustration. But let's say you've got 3 different sections of the same course, and let's say you're doing course assessment. You got sections 1, 2, and 3. Section 1 is 20 students, but section 2 only has 6, and section 3 only has 3 students. So at WCC, we wouldn't run these, but I've taught at schools where, tiny schools where I remember I had a differential equations class with 3 students in it. So, it could happen. And this could be, like 35. I've had sections of 35, and then I've had sections of 13 or 15. You could have a big disparity in the number of students across sections of the same class. Okay, I've calculated the mean for all 3 of these sections. So again, you just add up all the scores, divide by the number of scores. This is, the sum of these 20 scores divided by 20. The 89.17 is the sum of these 6 scores divided by 6. And of course, these 3 added up divided by 3 gives me this one. If you wanted to average across all 3 sections, which is something we would often want to do in assessment, in my opinion, it would be a mistake to do this, although it is a sort of an open philosophical question. If you were to take the means and then calculate the mean of the means, in other words, add these 3 green numbers up and divide by 3, you'd get 84.2. However, if you add up all 29 scores in all 3 sections, so 20, 6, and 3, add them all up, divide by 29, you would get 73.52. So as I say here, which one of these numbers best represents the average student score in this course? If you're thinking about the entire course, all 3 sections, I would argue that the 73 is a much more accurate reflection of the average student performance than the 84.2. However, someone might argue, well, I kind of think of the unit of assessment as a class, as a section, and maybe this is a night class and this is a day class, and they need to have equal weight. We were talking about this with Strata earlier this morning. Treat them equally. And there's some reasonable arguments you could make to use this number. The point I'm making here is just that these numbers are very different. And depending on which one you use, you're going to kind of get a different view of things based on different assumptions about what you're really measuring. The bottom line is you're measuring different things. The mean of the means is measuring something different than the mean of the pooled data, as we would call it. So don't do this unless you know what you're doing, which really means unless you're doing it intentionally and you understand the consequences of it and you can defend it. And then you can send it to the assessment committee and see what they think, and they might agree or disagree, but at least you both know what you're talking about. Okay, so finally, this is kind of tricky, but this is really significant, I think, and I ran into this when I did assessment of Math 197 last time. If we look at this performance tool, it had a 5-point rubric, and that resulted in the results being the same, whether I was using a 70% cutoff, 75%, or 80%. This was all 15 out of 20, which gave me 75%. But it's worse than that. This one actually is okay, because 80% corresponds to an actual value you can get, an actual score you can get. But if I used, for example, 75%, you can't get 75%. If you're a student doing this performance, you can't get 75%. You can only get 60% or 80%. Those are the closest. So I would say that this rubric is not consistent with this standard. You're using a standard, you're trying to measure something that cannot be by design this size, if you will. You cannot get this score. Here are 2 questions, question 1 and question 2, again, hypothetical questions for 20 different students. This is a 4-point rubric, so you could get anywhere between 0 0 and 4 points on this question. So this is the proportion for these students, and then this is their success rate. Question 2 is out of a 5-point rubric. And this is a proportion, and this is their success rate. And if your standard of success is 70%, will score 70% or higher. With your 4-point rubric, you can't get 70%. You can get 50%. You can get 75%. That's it. Nobody can get 70%. And you might say, well, what's the big deal? Well, the big deal is you're claiming that your standard is 70%, but your actual standard is 75%. In order to get 70%, somebody has to get actually 75%. So you're kind of selling yourself short. If you're using a 4-point rubric, you might as well say your standard of success is 75% because that's what it actually is. Likewise, if you're using a 5-point rubric, it's kind of counterintuitive because 5 points is more, should be better in some sense, more detailed, but actually it's worse just because of the way the numbers fall out. You're really using an 80% cutoff. You would say 70% is a success, but really it's got to be 80%. Because you cannot get 70% here. And I ran into this when I was doing the assessment for Math 197. We had a math department rubric, and it was 0, 1, 2, 3, 4. But then our standard for success is 70% will score 70% or higher. So I had to redo all of the grading of all the exams and convert it to a 10-point rubric. Because if you want to be able to actually get 70%, you have to have at least 10 points in your rubric. You could have more, but you have to have at least 10. So I had to rescore all the exams, which took me a long, long time. And while I was doing it, I was whining about this whole situation. What happened probably happens very often, which is you needed a departmental rubric. So, okay, let's come up with some rubric that makes sense based just on how do we grade? Okay, sure. But it's isolated, and we did not create a rubric at the same time that we were going to choosing our standard of success. And so when we have to choose a standard of success for assessment, we think just in isolation, well, what seems good? 70%, that's a C, right? It's a C minus, it's like a pass. Yeah, we passed. Okay, we're gonna use 70% for the students, so what should we use to assess the course? Well, I don't know, let's quote unquote grade ourselves the same way, 70%, right? We're doing okay. But in context, this makes no sense with our rubric. And frankly, it doesn't even make sense with a lot of our courses. For example, in calculus, you cannot take Calc 2 unless you pass Calc 1 with a C or better. So you can get credit for Calc 1 with a D, but you won't be able to take Calc 2. And we do that on purpose because, of course, we feel like if you got a D in Calc 1, you're not ready for Calc 2. It wouldn't be right to let you take Calc 2. Unless you know Calc 1 better. So if a student gets 70% in my grading scale, that's a C minus. Now, some of the math faculty don't give C minuses for this reason. They say, well, a 70% is a C. There's good reason for that. But I use the same grading scale for all my courses, and 70, 71, and 72 is a C minus. So somebody could pass the assessment standard and fail the class in terms of succeeding in the sequence of courses. So from that perspective, I think the rubric and our standard of success is not consistent with our other standard of success for someone completing the sequence of courses. The moral of the story is to think about all of these things together, and course curriculum and course assessment and grading our courses, just using a final exam for a grade, all exists within a context. And I have found the hard way that you can save a lot of pain and suffering and work if you think about that context in advance and take advantage of our academic freedom. We get to write this stuff. We have a lot of say about what standards we're going to use, what tools we're going to use. So let's tee ourselves up to make it as easy as possible.